Tandaan po natin na if we are given with a network of resistors connected in series, currents of those resistors given in that network are all the same with each other. So that means, say for instance, given this particular network, resistors connected in series, so whatever will be our I subtotal, so that will also be the value of our I sub 1, I sub 2, I sub 3, and so on and so forth. Tandaan po natin, if resistors are connected in series, yung mga current, pare-pareho lang po. Magkaiba-iba lamang po yung ating mga voltages. Tandaan po natin that the sum of the voltages across each resistor is equal to the voltage across the network. So if we have the n resistors connected in series, the total voltage across the network is expressed by the equation given in your screen. For us to get the total voltage of that network, we have to add lang po V sub 1, V sub 2, V sub 3, and so on and so forth. We have also to consider that given our resistors connected in series, each voltage drop across resistor is different from the other resistors. Kung ano po yung value ni V sub 1 is different from the value of your V sub 2, V sub 3, and so on and so forth. Ayan ha. But then, kung ano po yung value ni I sub total, yan din po yung value ni I sub 1, ni I sub 2, ni I sub 3, and so on and so forth. So you have to make sure that your total voltage is equal to the summation of all of these voltages. Tandaan po natin yan. So let me proceed my discussion on the network of resistors connected naman in parallel. So, same is true po sa ating network of resistors connected in series. For us to get the total na current, we have to just get the summation of all the currents in our network. But then, with respect to our current, with our voltage, for the network of resistors connected in parallel, say for instance, given this network, ang ating pong mga individual current, magkakaiba po sa current na nag-flow across sa ibang resistor. Example, yung I sub 1 po natin dito, iba po yung value niya sa I sub 2. Yung I sub 2 naman, iba rin yung value niya sa I sub 3, and so on and so forth. But, with respect to our voltage, kung ano po yung total voltage natin, that is also equal to our V sub 1, equal to our V sub 2, equal to our V sub 3, and so on and so forth. If we have to get the summation of I sub 1, I sub 2, I sub 3, and so on and so forth, that is our total current. Whereas, the value of our total voltage is equal to the value of V sub 1 itself. The value of the total voltage is equal to the value of V sub 2 also, and so on and so forth. Yan po sa ating resistors connected in parallel. So, dito po tayo sa example po natin for us to have an application of this discussion. Sabi ng example number 1 po natin, below is a series circuit with a terminal voltage of 12 volts connected to a circuit consisting of 4 15 ohms and 1 25 ohms resistors in series. So problems are, calculate the equivalent resistance for A. For B, calculate the current through each resistor. And for C, calculate the potential drop across each resistor. So there we have our network. Ano yung unang hahanapan natin ng value? The equivalent resistance. Let me denote that one as R sub EQ. Since our resistors are connected in series, it is easy for us to identify the equivalent resistance by just adding all of those resistances, diba? So, ang formula po ng ating equivalent resistance with resistors connected in series is R sub 1 plus R sub 2 plus R sub 3 plus R sub 4 plus R sub 5. Substitution, R sub 1, that's 15 ohms, plus R sub 2, that's another 15 ohms, plus R sub 3, 15 ohms, plus R sub 4, 15 ohms, plus R sub 5, that's 25 ohms. So, our equivalent resistance is 85 ohms. Ladies and gentlemen, this is our answer for letter A. So, proceed tayo sa problem letter B. We have to calculate the current through each resistor. Given that network, ano nga po yung sabi ko kanina? Given that network, ano po yung similar with each other? Is it the current or is it the voltage? Tandaan po natin, basta ang network natin with resistors connected in series, ang same po na quantity ang current. Tapos, different sila sa ilahang mga voltage. So, ibig sabihin, ang voltage nga ara sa R sub 1, iba kay R sub 2, iba po kay R sub 3. Pero, ang current na nag-flow kay R sub 1, similar lang kay R sub 2, kay R sub 3, kay R sub 4, o R sub 5. Kung given naman po tayo ng network with resistors connected in parallel naman, ang magkapare-pareho naman sa kanila si voltage. Tapos, ang atuan naman po na magkaiba-iba sa ilaha kay si current. So, since kaming problem na to, for example, number 1, resistors man connected in series. Ang pare-pareho sa kanila kay current. Ang magkaiba-iba sa kanila kay si voltage. Now, balik tayo kay problem letter B. Sabi dyan, calculate the current through each resistor. Current ni R sub 1, R sub 2, R sub 3, R sub 4, ug R sub 5. So, okay lang po nga di na nato isolve to sila simply because ang current manggod nga mosulod sa ila tanan-tanan pare-pareho lang. So, unsa tong buhaton? Isolve lang nato anay ang total current ng network na ito. Tama? So, paano natin i-solve ang total current? We will be using our Ohm's law, which states that V is equal to IR. Divide both side by R, then R, cancel out, cancel out. So, the total current natin ngayon is V over R. Ang V there, that's the total voltage, at yung R there, that's the equivalent resistance. So, substitution, V sub T, it's 12 volts. At saka the R sub EQ, it's 85 ohms. 12 divided by 85 is 0.14117,647,647, and the unit is ampere. So, since ang nagapangita kay current through each resistor, so, imo siyang specify na lang po dito na ay 1 to I5 equals 0.14 amperes. And this is na the answer. Pwede rin na you will be specifying each na mga current. So, pwede ka nga mag-I sub 1 equals 0.14 ampere. Dari ka na po I sub 2, 0.14 ampere. So, proceed tayo kay letter C Calculate the potential drop across each resistor. Pag sinabi pong potential, ano po yung other term for this? So, ang hinahanap natin dito is the voltage drop across each resistor. Ibig sabihin, hahanapin natin yung value ni V sub 1, ni V sub 2, V sub 3, V sub 4, at saka ni V sub 5. Kasi sabi ko nga, pag ang resistors connected in series, magkakaiba po ang kanilang mga voltage drops. So, let's start with our V sub 1. So, ang V sub 1, may formula siya na I sub 1 times R sub 1. Substitution, I sub 1, that is 0.14117647 amperes. So, kailangan complete yung actual na value na pinakita ni calculator sa inyo kasi nga po, we are still in the solution process. Times yung ating R sub 1, which is 15 ohms. 0.14117647 times 15, and that is 2.1176470. 0.59 and the unit is volts. So our V sub 1 now is 2.12 volts. So since for V sub 2, V sub 3, and V sub 4, they have the same value for the resistance, so most probably ang V sub 2 is also equal to 2.12 volts. Ang V sub 3 is also equal to 2.12 volts. Ang V sub 4 is still 2.12 volts. So, yan po. Next, for the V sub 5 naman, so I sub 5 times R sub 5. So, ang I sub 5 po natin, it's 0.14117647 amperes times R sub 5 po natin is 25 ohms. So, our V sub 5 now becomes 3.53 volts. And this is for our V sub 5. For us to satisfy our condition kanina na the summation of all of these voltage drops is equal to our V sub t, let's validate our answers. So, V sub t equals V sub 1 plus V sub 2 plus V sub 3 plus V sub 4 plus V sub 5. Substitution, so V sub t natin, that's 12 volts. Then, ang V sub 1, that is 2.12 volts. Ita-times ko na lang siya sa 4, plus ang V sub 5 po natin is 3.53 volts. 12.01. And that is approximately equal to our V sub t. Now this time, let's have another example. We will be having a network with resistors connected in parallel. So, meron tayong dalawang resistors, R sub 1 and R sub 2. For R sub 1, we have 12 ohms. And for the R sub 2, we have 8 ohms. And they are connected in parallel. And the parallel connection is attached to a V sub t, which is equal to 12 volts as our voltage source. For letter A, find the equivalent resistance. For letter B, calculate the current supplied by the source to the parallel circuit. And letter C, calculate the current in each resistor, and we will show that it is equal to the total current. So let's start with letter A. Ang sabi dyan is we have to find the equivalent resistance daw. So let me denote that one as R sub EQ. And for us to solve our equivalent resistance, and since we are given by just two resistors, we can use the formula R sub 1 times R sub 2 divided by R sub 1 plus R sub 2. Substitution tayo. Ang R sub 1 po natin is 12 ohms times ang R sub 2 natin is 8 ohms. Divided by 12 plus 8. So, our R sub EQ is 4.8 and the unit is ohms. This is our answer for letter A. Proceed po tayo kay letter B. At ang sabi ni letter B, we will calculate the current supplied by the source to the parallel circuit. So therefore, we have to determine the value of our I subtotal. So for us to solve the I total, let's follow the formula V is equal to IR. So divide both sides by R. R, cancel out, I subtotal natin is equal to V over R. Where V there, that is our V sub T, and our R here, it's R sub EQ. Substitution, V sub T, that's 12 volts, divided by our R sub EQ, that is 4.8 ohms. 12 divided by 4.8, that is 2.5 amperes. So, this is our final answer. Proceed tayo kay letter C. Ang sabi ni letter C, we have to calculate the current in each resistor. Then, let's show that is equal to the total current. Going back to our network, there we are given with two resistors connected in parallel. So, ano po yung magkapareho sa kanilang dalawa? Is it the current or is it the voltage? Okay, voltage po ang pareho sa kanila. So, kung ano po yung voltage ni R sub 1, yun din po yung voltage ni R sub 2. At kung ano po yung mga voltage nila, yun din po yung voltage ni V sub T po natin. So, it is safer to say that the voltage across R sub 1, that's 12 volts, And the voltage across R sub 2, that's 12 volts also. So we have to calculate the current in each resistor. So for I sub 1, we have the formula V sub 1 over R sub 1. So substitution, V sub 1, that is 12 volts. And our R sub 1, that is 12 ohm. 12 divided by 12, that is 1 ampere. For our I sub 2 naman, so formula is V sub 2 over R sub 2. So V sub 2, that is 12 volts again. And R sub 2, that is 8 ohms. 12 divided by 8, that is 1.5 amperes. And this is the final answer. Now, let's show the summation of these is equal to the total current natin. So, let's have I sub t is equal to I sub 1 plus I sub 2. I sub t, that is 2.5 amperes. Then, ang I sub 1 po natin, that is 1 ampere. At saka ang I sub 2 natin, that's 1.5 amperes. So, 2.5 amperes equals 1 plus 1.5, that is 2.5 amperes. And they are equal. Tapos na po tayo sa network with resistors that are connected in series and in parallel. Now, proceed po tayo sa discussion ng Kirchhoff's rules. The Kirchhoff, please take note of the spelling, double H, double F. The Kirchhoff's rules are also known as the laws of electric networks. Ang Kirchhoff's rules, may dalawa po itong types. Una, we have yung tinatawag nating KCL, or the Kirchhoff's current law, or minsan tinatawag din siyang junction rule. And yung pangalawa naman is yung ating tinatawag na KVL, or Kirchhoff voltage law, or minsan tinatawag din itong loop rule. These rules were formulated on 1847 by a German physicist, Gustav Robert Kirchhoff. He was born 1824 and died 1887. Let's start discussing on Kirchhoff's current law, or the KCL, also known as the junction rule. Ang sabi po ni KCL, at any junction point, the sum of all currents entering the junction must be equal the sum of all currents leaving the junction. Sa ating pang salita, kung ano po yung mga currents na pumapasok ay equal lang sa sum ng currents na lumalabas. Alam po ba natin yung tinatawag na junction? Pag sinabi pong junction, say for instance, may wire po ako dito. Ayan. So, connected po siya sa mga other elements there. Tapos, nagkaroon po ako ng parallel connection dito. Ayan. Sa isang other element, another wire. At isang parallel connection naman sa iba namang element. Yung intersection po ng mga wires po natin, yun na po yung tinatawag nating junction, or sometimes known to be as node. Ayan. Kaya sa electrical engineering, may tinatawag ding nodal analysis. Kasi nakabase po siya sa tinatawag nating Kirchhoff's current law. Okay na po tayo dito. Ang sabi din ng SSLM ninyo, in addition to this description, the KCL states that the algebraic sum of the currents entering and leaving any node or junction in an electric circuit is equal to 0. Sa ating salita, ang sum or total ng mga kuryenteng pumapasok at ng mga kuryenteng lumalabas sa node or sa junction na iyon ay equal siya sa 0. Mathematically, it is expressed as the summation of our I sub n, where n starts from 1 and the capital letter N there signifies the number of the current or of the nodes is equal to 0. Yan po. So, if we have to consider our diagram given in your screen, may isang node po dyan. Ito po yung node ng ating diagram. Ayan po. Ito po yon. Yan po yung node ng ating diagram. Sa node ng diagram natin, ilan ba ang kuryenteng pumapasok at lumalabas? 6. And those are being denoted with our subscripts there. So, ibig sabihin, kung may 6 po tayong pumapasok at lumalabas, ilan ang pumapasok sa node? 3. And those are I sub 1, I sub 2. Ano pa?
I sub 2.
Okay, very good. And the rest of the currents are leaving the nodes. And those are I sub 4, I sub 5, and I sub 6. For us to satisfy this description, ang sabi daw dyan is the summation of I sub 1, I sub 2, at saka I sub 3 should be equal to the summation ng mga lumalabas na kuryente. And those are I sub 4 plus I sub 5 plus I sub 6. And here, ladies and gentlemen, we have already satisfied the statement na the sum of all currents entering the junction must be equal the sum of all currents leaving the junction. If we want naman to equate this to 0, ang gagawin po natin, itatranspose na po natin yung mga terms na andun sa right-hand side of the equation to the left-hand side of the equation. And that becomes I sub 1 plus I sub 2 plus I sub 3 minus I sub 4 minus I sub 5 minus I sub 6 equals 0. And ladies and gentlemen, we have already satisfied the statement. The algebraic sum of the currents entering and leaving any node or junction in an electric circuit is equal to 0. Also remember, according to your SSLM, that we have to use this convention na pag papasok siya sa node, positive ang current. Pag lumabas siya sa node, negative ang current. Take a look on node 1 in the diagram. Ano-ano yung mga currents that are entering and leaving the node? Yung pumapasok, it's I sub 1 and I sub 3, I sub 2, and I sub 4 are leaving the node. Given po that premise, ano po yung magiging equation natin sa node 1 following KCL? Ang I sub 1 daw yung pumapasok, so that's positive. Tama. Ang I sub 2 lumabas, that's negative. Tama. I sub 3 yung lumabas, that's negative. Tama. I sub 4 lumabas, that's negative. Tama. Very good. So, ibig sabihin, equation natin sa node 1, I sub 1 minus I sub 2 minus I sub 3 minus I sub 4 equals 0. So, take a look on node 2. Ano po yung magiging equation ng node 2 po natin? I sub 2 plus I sub 3 plus I sub 4 minus I sub 1 equals 0. Or you may also rearrange the terms, negative I sub 1 plus I sub 2 plus I sub 3 plus I sub 4 equals 0. Those are our equations for node 1 and node 2. We're done with KCL. Then this time, let's proceed to KVL. The KVL or Kirchhoff's voltage law, again, also known as the loop rule. Sabi niya, the sum of the changes in potential around any closed path of a circuit must be 0. So it is similar with our KCL, but instead of using current, here we will be using voltage. Pero, hindi po siya per node ang kanya nasa analysis, but we are using loops here or mesh. So, say for instance, given po tayo ng ganitong network, yan po yung tinatawag nating loop. So, either in counterclockwise or in clockwise motion. In your SSLM, KCL states that the algebraic sum of the voltage drops and the supply voltages in any closed path or loop in a circuit is 0. Diba? Sabi ko nga po, pareho lang siya sa KCL natin. But instead of using current, we will be using here voltage. And instead of using or analyzing the node, here we are analyzing the loop or the closed path. Ayan po yung ating representation on how to analyze our diagram using KVL. Tandaan po natin na for bullet number 1, If loops enter on minus and goes out on plus, so positive ang voltage. If loops enter on plus and goes out on minus, negative ang voltage. Para mas lalong maintindihan, kung nag-travel ta from this corner, so pak, uy, may nasugatan ta na battery. So, patuloy na tayo sa paglalakbay. Pak. Ang nagawasan nato kay si positive. Therefore, ang i-consider nato is positive na sign. So, V sub S1. Tandaan, kung unsa ang gigawasan, mauto ang imuhang i-consider na sign. Sir, pwede ba ang ako ang gisudlan? Mauto akong i-consider na sign? Pwede, as long as we have to be consistent of our convention used. So, patuloy po ako sa pag-travel ko, ha? Anong paana man ka, sir? Ano, di ba pwede nga dili ka mag-start, sir? Dili pwede ni. Kaya ano man, ang loop na to, pa-clockwise. Sige, patuloy po ako sa aking paglalakbay. Uy, may battery. So, tantaw na kung sa ako ang gawasan na sign. Ay, positive. So, plus V sub S2. Patuloy ako sa paglalakbay. Uy, na ay resistor. So, mugawas ko. Negative. So, negative V sub 1. Then, patuloy sa paglalakbay. Another resistor. Negative. So, negative V sub 2 and humana equals 0. Ladies and gentlemen, our equation for this loop is V sub S1 plus V sub S2 minus V sub 1 minus V sub 2 equals 0. And we already satisfied the statement na the algebraic sum of the voltage drops and the supply voltages in any closed path or loop in a circuit is 0. So, proceed po tayo sa example number 3. The given circuit consists of two supply voltages, V sub S1 and V sub S2, which is equal to 6 volts. So, 6 volts dito at saka yung sa isang battery, 6 volts pa rin. And you have 3 resistors, R sub 1, R sub 2, and R sub 3. All of them are equal 3 ohms. Lagyan ko po dito ng 3 ohms. Dito naman, another 3 ohms. Dito, again, it's another 3 ohms. Ayan. Find the following. Letter A, the current through each resistor. And letter B, the voltage drops of each resistor. So, for letter A, ang hahanapan po natin ng value kay the current. For letter B, the voltage. So, ano po yung gagamitin natin? Now, tandaan, if we are given with 2 or more na mga voltage sources, then we will be using KCL na po at saka KVL. Okay lang din po if you will be using yung previous natin na discussion kanina, but then the analysis as well as the calculation might be complex. So, para mas madali na lang po, then we will be using the KCL as well as the KVL na lang. For letter A, the current through each resistor, since we have to determine the value of each current through each resistor, so it is appropriate to determine the equation using KCL muna. So, mag-KCL po ako dito ha. So, sa KCL, ang tandaan lang po natin is yung node natin. So, dito sa problem, okay lang, kasi binigay na ni problem kung saan banda ang node na kailangan natin bigyan ng or tuunan ng pansin. Pero what if wala po tayong node na label sa isang problem? Basta meron po tayong intersection of our wires, tapos yung wires na yun connected sa mga other elements. May node na po na tinatawag iyon. And usually, ang node po is represented by a shaded po na circle or small circle. Other than node A, meron pa po ba tayong nodes meron pa po itong node na dito sa may baba. But this can be neglected because this node na po is connected directly to the ground. Bakit ko po nasabi? Kung mapapansin po natin, connected po both yung kabilang wires sa negative polarity ng mga batteries po natin. So most probably, connected na po ang node na yan sa ground, and obviously ground is equal to 0. Tama? So that can be neglected na po. So ang isang kailangan na pagtuunan ng pansin dito, yung isang node na obviously na label na ng ating problem. Sa node A po natin, ilan po yung currents entering and leaving? We have 3 currents, and those are I sub 1, I sub 2, at saka si I sub 3. I sub 1 minus I sub 2 plus I sub 3 equals 0. And this serves as our equation number 1. 1 equation 3 unknowns, masasolve ba? Hindi. Hindi po natin siya masasolve kasi kulang pa po tayo ng equation. So, ano po yung ating gagawin para masolve po natin yung mga variables na andan sa ating equation na yan? And that is where our KVL comes in na po. So, ngayon, gagawa ako ng equations ng KVL po natin. Ilang loops meron tayo? We have 2 loops. The loop 1 and the loop 2. Ang loop 1 follows clockwise motion. Loop A, follows clockwise motion, whereas loop B follows counterclockwise motion. So, let's start with loop A. So, ano po yung ating equation? Tandaan, ang giyawasan mautoy sign na ato ang sundon. So, dali ko mag-start ha. So, dali. So, pak. Uy! Plus. So, positive V sub S2. Next. Pak. Oh! Negative V sub 1. Pak. Oh! Negative V sub 2 equals 0. And this is our equation number 2. Then, I will now be formulating my equation for loop B. So, dito tayo mag-start. Plus V sub S1. Negative V sub 3. Negative V sub 2 equals 0. And this is our equation 3. I sub 1 minus I sub 2 plus I sub 3 equals 0. Equation 1. Next, V sub S2 minus V sub 1 minus V sub 2 equals 0. And this is our equation number 2. V sub S1 minus V sub 3 minus V sub 2 equals 0. Ayan na po. 3 equations, pero multiple unknowns. Diba? Iba-iba mangkod. 3 equations. Sa first equation, puro I. Second and third equation, puro V. So, paano man na ron? Ana na. So, paano ito siya na masolusyonan? Balik ta sa ato ang problem letter A. Ang sabi dyan, the current through each resistor. Ang gagawin po natin, i-expound po natin yung equation number 2 na yung V dyan, gagawin po nating I. Para later on, we can use equation number 1. Nakuha? Paano yon? Balik po tayo sa Ohm's Law po natin. Sabi ni Ohm's Law, ang V daw is equal to IR. So, ibig sabihin, pwede po natin gamitin ang IR na term to substitute our V. Tama? Paano po iyon? Dito po ako kay equation number 2. Yung V sub S2, given na po yan sa ating problem, which is 6. Tama? So, automatic ko na po siya dito 6 ha. Minus ang V sub 1, that is I sub 1, times R sub 1 minus I sub 2 times r sub 2 equals 0. Or, pwede siya maging 6 minus I sub 1, ang r sub 1, that is 3. 3, tama? Minus I sub 2, ang r sub 2 natin, 3 pa rin yon, equals 0. Or, pwede po nato siya ingnon nga, 6 minus 3 times I sub 1 minus 3 times I sub 2 equals 0. And this is our equation 2 also. Kung mapapansin po ninyo, sa equation natin, puro I na. So, magagamit na po natin siya mamaya kay equation 1. Diba? Ang saya-saya, no? Nice, no? So, V sub S1, that's 6, minus V sub 3, that's I sub 3, times R sub 3, minus V sub 2, I sub 2, times R sub 2, equals 0. Or, 6 minus I sub 3 times 3, minus I sub 2 times 3, equals 0. Or, 6 minus 3I sub 3 minus 3I sub 2 equals 0. Our equation 3. Sige po. So, here we have I sub 1 minus I sub 2 plus I sub 3 equals 0. Equation number 1. Next, 3 I sub 1 plus 3 I sub 2 equals 6. Equation 2. Next, 3 I sub 2 plus 3 I sub 3 equals 6. Equation 3. Equation 2. 6 minus 3 sub 1 minus 3 I sub 2 equals 0. Transpose po natin siya. So, 6 equals, ang negative magiging positive, 3 times I sub 1, ang negative magiging positive, 3 times I sub 2. Or, 3 times I sub 1 plus 3 times I sub 2 equals 6. Same po siya dito. Similar lang pa din po yan siya sa equation number 3. Sige po, so 3 equations, 3 unknowns, masolve na ba o hindi pa? Okay, nakaayo. So you can solve this one using the Gaussian elimination, or you can use it also another method, Kramer's rule. Ayan, so pili lang mo dala sa dalawa kung diin na inyong gusto, either Gaussian or Kramer's rule.